Hello everyone, come back. My name is Naresh Chetri. So today, as you have already seen, we are going to talk about Diffie-Hellman algorithm. Okay, so one of the powerful algorithm for exchanging the key between the sender and receiver without passing them from the public channel, and it is also popular because this is one of the key used in algorithm using symmetric cryptography. Yeah, we are not talking about the asymmetric. So in the last video, I talked a little bit about the symmetric and the asymmetric. The asymmetric cryptography are those which use the RSA algorithm, the ECC, the elliptic curve cryptography. So we will talk those about RSA and the elliptic curve cryptography in our next video. But here we are Diffie-Hellman algorithm, so which is the four-step process. Typically the last one, when we compare the keys, we can say them that it is a fifth step, but normally the four-step to exchange the keys between sender, the Alice, which we say Alice is trying to send her the message to the Bob, which the Bob we say is the receiver on the other end. So the algorithm, which is pretty simple, so it starts with two prime number, and unlike doing the straight way, here the users means Alice and the Bob, will do some extra steps to protect the key. What that means, whenever it comes to the creation and distribution of the symmetric key, this algorithm is based on the mathematical function. It is used for the keys agreement. So that means we use public key and the private. The public key, as you can see, the public numbers, so which we can say the public number is PNG, and two others are private ones. So the private means A and B, which Alice and Bob choose to use A and B, and with this PNG we compute A1 and B1. Okay, so the both parties choose a private key. That's, I have said, the private key is A and B, and then calculates the public keys. So how they calculate the public key? That's what we are talking. So in this way, so Alice calculates A1, Bob calculates B1. That, and then they share those keys. So that means they share, or they exchange those keys. So Alice exchanges that keys to Bob, and Bob exchanges that keys to Alice. And then they compute the secret key on the end. So we will go one by one. The step is pretty simple. So there are several other methods for the exchanging the secret keys, like offline distribution, public key encryption, and Diffie-Hellman algorithm. So when we talk about this, is the third one, the Diffie-Hellman algorithm we are talking, other than the two, offline distribution and public key encryption. And we will also see the implementation code, this code, Python programming language, which is pretty simple. So the first one, the public prime number for Alice, as you can see, we have chosen the prime number as 23. You can choose any other number, but there we have used a prime checker function. So this is one function, prime checker pi, added as one Python modules. So if you don't understand what exactly is the Python function and Python modules, please go back and watch my videos about the Pythons. There are so many programs related to Python functions. The second one, we have to choose the primitive root, which is also a prime number of Bob based on Alice. So here we choose G as a 11, and if that primitive root is not n, then there is the primitive root should exist, and we have used another function. Function means another Python function, so primitive check.py. So this is, so apart from the main file which we have for Python programming, so this one is the second and this one is the third file. There are three files, or three Python files, trying to make the things easy. Seeing the code, I hope you will understand the exact implemented in the Python. For now, just remember the first one is the main file, the algorithm .py. The second one is the prime checker, and third one is the primitive checker, just to check, to verify the condition. Then come the private key. So the private key now chosen by Alice. She chose private key as 3, and Bob chose the private key as 4. Well, you can already see the step 2. But there is another condition that the private keys chosen by Bob and Alice must be less than P. So in the sense that must be less than 23, but here that's why we have chosen 3 and 4, which is obviously less than 23. The error will be generated in the program. Then Alice calculate the public key A1. So here how the A1 is calculated, so G raised to the power of A modulus P. So the G means 11 raised to the power of A, so 11 raised to the power of 3. And the mode means the modulus, use this modulus symbol, Python programming language, just to represent the remainder. Okay, then whatever the results will come, that means 11 raised to the power of 3 modulus 23 will give us 20, and that is sent to the Bob, or that is exchanged. In the same way Bob does that, so g raised to the power of b comes 13, and that is exchanged. So that's why it says it is Ellis sent to Bob and Bob sent to Ellis. So here these are the public key that are exchanged in order to generate the secret key. Now Alice compute her secret key, gets key 1 equal to 12, and Bob computes the secret key 2 equal to 12. So how? So the B1 raised to the power modulus P and A1 raised to the B modulus, when you get the result, you get exactly the same number. That means whenever K1 is equal to K2, then key exchange is success. Otherwise, if the both numbers are not equal, the key is unsuccess. Okay, the key's exchange is unsuccess. Here, our key 1 equals now. So this is just the 4 or 5 step of the algorithm. Computation is on step 3, and step 4 we'll see that. So the major computation in the sense or calculation for the public key, we can say PU, and this is the calculation for the secret key. The secret key has to be same in order to perform or successfully perform the, like I said, I have tried to describe everything. The first thing, we import the file. We made an alias as the module, and I have said the Python file prime checker. You can check that Python file over here. This is just couple lines of code just to check whether a number is prime or not. I hope you have done that program several times before just to check. Here, the only difference is that we have made a separate module as a prime checker.py to make it easier, so that we can use it, or we can. And the second module needed is the primitive check. So the primitive check, so again we have used the same thing, made another module, primitive check.py, that check if the function is the primitive root or not of the p, so whatever entered by the user. Okay, so now here we start with the empty list L, and these line are just the description. These are the same thing whatever you see over there in the PPT. I have also posted over here so that you can recall that. Now the only thing is that please enter the public prime number for the Alice. So here we have to enter the public prime number. So let's say enter 23, and then it asks for the primitive root of 23. That's what. So if we don't enter, it will go ahead and check that primitive checker which we have defined over here, but we have entered the prime number. And now, so for the sake of the comment, I have also put over here the number 23 has 10 primitive roots. You can go ahead and learn more about the primitive roots later, but for now understand. So out of these 10 primitive roots, we can use any one of in our program, because we have entered P, the first prime number is 23. So for now, I just use 11. Okay, and then whatever it asks is the private keys. So this is the step 3 and step 4 private keys. Okay, A and B. So A for Alice, B for Bob, which is so simple. We have used the input function, which is pretty common in the Python programming language. Just that has been typecast to use the integer as the integer value. Otherwise, it will take as a string value. Okay, then again, that whatever I have said, that keys should be less than P. That means this both number, we have used 3 and 4. If you remember, that both numbers should be less than 23. So here is the condition. I enter is 3, the value of A, and 4 is the value of, so P means for private key for Bob. Compute A1 and B1. A1 is computed as the power G power A, that works in this way. The power function in Python programming language. The modulus, as I said before, is use the percentage sign. So whenever you compute G power A modulus P, that means 11 power 3 modulus 23. Okay, 11 power 3 means it will be 1331 modulus 23. That gives us 20. So the value of A1 also printed here is 20. That is sent to Bob. And in the same way, the value of 20 and 13 is exchanged. And with the help of 20 and 13, we compute K1 and K2 in the same way. So you can see B1 power A. So B1 power A means the 13 power 3 mod 23. That will give us 2197 modulus 23, give us 12. And again, 20 power 4 modulus 23. So the 20 power 4 is 163 000 modulus 23 key was 12. And the end we have and just printed the A1 and B1 value and the secret key. I've said if K1 equal to K2 is like we have said in the algorithm, then the key's exchange is success. This help to understand the Diffie-Hellman algorithm with the implementation in Python. Thank you for watching.